Hello students, this is session number 3 of chapter 9 alcohols. By the end of this session, you should be able to recognize the chemical reactivity of secondary and tertiary alcohols. Let us first start with chemical reactions involving secondary alcohols and especially mild oxidation of secondary alcohols. Do you still remember what is meant by mild oxidation? Mild oxidation is a reaction that takes place without breaking the carbon chain. Mild oxidation of secondary alcohols, as in case of primary alcohols, is needed in 3 cases. Mild oxidation using oxidants, catalytic dehydrogenation in absence of oxygen, and catalytic oxidation in presence of oxygen. Remember this map? Can you say it alone? Primary alcohols undergo what? Oxidation. What they do? They give us aldehyde, and this aldehyde can undergo more oxidation to give us carboxylic acids. But the case of secondary alcohols is a little bit different. Secondary alcohols make oxidation reactions and give us ketones, not aldehydes, ketones. But these ketones cannot undergo more oxidation reactions. So, oxidation of secondary alcohols takes place in only one step and stops at ketone, whatever the oxidizing agent present is and whatever the amount of oxidizing agent present. Okay, now let us start with catalytic oxidation of secondary alcohols in the presence of O2. This is a secondary alcohol. You still remember secondary alcohols? You still remember that their functional carbon is bound to 2 alkyl groups, you know? Okay, so secondary alcohols in the presence of oxygen, gas, and heated copper as a catalyst. This copper must be heated until it becomes red, okay? It gives us a ketone and H2O. How does the reaction take place? Look, in fact, oxygen is found in the atmosphere as O2. So oxygen gas is found in our atmosphere as O2. We cannot find one O only. It is impossible to find one O in the atmosphere. In the atmosphere we have O2. So when the reaction takes place, only one atom of this molecule is involved in the reaction. Half O2 means half this molecule. Means one atom of this molecule is taken with 2 hydrogen atoms. So O with H2 together, they give us H2O. The other atom is not involved at all in this reaction. For this, we have written here half O2. Okay, so H2 are removed with one oxygen to give H2O, and these hydrogens which are removed are replaced with a double bond. So a ketone is formed. This is the reaction. Now, what about this ketone? Can this ketone undergo further oxidation? Will this ketone give us a further product? Of course not. The reaction stops at ketone even if the oxygen is in excess or in great excess. This ketone stops here and this is the end of the reaction. Now it is your turn. Please try this application. You have 2 propanol. Okay, I will say nothing. It's your turn. So, H2O together, H2O and the ketone. Catalytic dehydrogenation in absence of O2. Dehydrogenation. What is meant by dehydrogenation? You still remember? It is a removal of H2. Okay? It also needs a catalyst which is copper and heat. What it will give us? H2 plus the ketone, isn't it? Okay, this is a ketone and H2. This ketone will not undergo any other reaction. It is also your turn. Do it yourself, please. H2O and the ketone. Now, oxidation in the presence of an oxidizing agent. It is the third reaction of oxidation reactions involving secondary alcohols. Secondary alcohols, when they make oxidation, they will give us what? Ketone. And this ketone, will it give us another product? No, even if the oxidizing agent is in excess. Okay, let us consider dichromate with secondary alcohols. Okay, dichromate will be reduced to Cr3 plus, and this secondary alcohol will be oxidized to a ketone. Let us do the balanced equation together. Cr2O7 2 minus, so 2Cr3 plus. Please note here Cr3 plus 7H2O, then 14H plus, and 6 electrons to balance the charge. This is the reduction half reaction. Secondary alcohol, it will give us a ketone. Okay, listen, you remember R and R prime are not involved in the reaction, so don't look at them at all while balancing. Only look at this part of the reaction. So you have only to add 2H plus 2 electrons. This is oxidation. Will you add these two half reactions directly? No. Why? Because here we have 6 electrons and here we have 2 electrons. We have to multiply here by 3 in order for the gained electrons and lost electrons to be equal. This is the overall 3 secondary alcohol with Cr2O7 2 minus, okay, and then 3 ketone and 2 Cr3 plus, and this is the balanced equation. You can transform this H plus into H3O plus by adding on the both sides H2O. 8 H2O here and 8 H2O here. 8 because here there is 8 H plus. So 8 H2O, I will have 8 H3O plus, and here I will have 15 H2O. And everything will be the same. Okay, right now you have to write the equation of reaction of 2-butanol with MnO4 minus by yourself. Yes, I am going to give you some hints. Okay? So 2-butanol, this is 2-butanol 1, 2, 3, 4, and on carbon number 2 you have OH. This is 2-butanol. By oxidation, this 2-butanol will become what? A ketone. Only here the change will occur, isn't it? So here square or circle this part and say for yourself only at this carbon, which is a functional carbon, changes will occur. Okay, so this alcohol become a ketone and everything else stays unchanged. You can even hide them to simplify the balancing. Okay, they do not interfere in the reaction, and then you can even hide them and do not count these hydrogens and carbon atoms. Now, one carbon atom at each side, one oxygen atom at each side, so both are balanced, but the hydrogens are not balanced. Here we have 2 hydrogens, so you have to add here 2 H plus and then 2 electrons to balance the charge. This is oxidation half reaction. Now please remove these squares. Okay, remove everything. Okay, another half equation is MnO4 minus. It gives Mn2 plus. Of course, we have 4 oxygen atoms, so we have to add 4 H2O here, and then 8 H plus here, and at last balance the charge by adding 5 electrons. Okay, so that the overall charge here is equal to the overall charge here. But now you are going to add these two half equations. Are you going to add them directly, or you will do a step before? Of course, you will do a step which is multiplying this equation by 2 and that by 5, so that the total of electrons, the total number of electrons lost by this reaction, which is equal to 10, will be equal to the total number of electrons gained by this reaction or half reaction, which is also 10. Now they can be added 5 alcohols with 2 MnO4 minus, 6H plus, and then 5 ketone molecules, 2 Mn2 plus, okay, 2, and 8H2. You can transform this H plus into H3O plus, and you can keep it like that, no problem. This is the end of oxidation of secondary alcohols. So let us make a summary. Oxidation of primary alcohols give us aldehyde and then carboxylic acids. Oxidation of secondary alcohols give us ketones, and now oxidation of tertiary alcohols. Oxidation of tertiary alcohols, in case of presence of oxygen or absence of oxygen or with an oxidizing agent, will not take place at all. So tertiary alcohols do not undergo oxidation reactions. Let us do this sample exercise. The complete combustion of 3.52 grams of a saturated monoalcohol A gives us water and carbon dioxide. Here is the equation of reaction. Alcohol A with oxygen give us carbon dioxide and water. At the conditions of this experiment, the molar volume is 25 liter per mole. So you are given the equation of reaction, and you have to show that the molecular formula of A is C5H12O. You have to show that this N is equal to 5. Okay? How will you start? Will you write this stoichiometric ratio? Okay. And CO2 can be found easily because V of CO2 is given, okay, 5 liters and 25 liter per mole, 0.2 mole. So here we have 0.2 mole. Okay, we still have to find N. N equals mass over molar mass. Bring the molar mass in terms of N. So the molar mass of A in terms of N is this. Okay, then back to here, mass N of A equals mass of A over molar mass of A, which is equal to 0.2 mole over N. By cross multiplication, you have found molar mass in terms of N. Okay, and then N can be found later. Therefore, the molecular formula of A is C5H12. Part 2. Knowing that the carbon chain of A is linear, write all the possible condensed structural formulas of A and give their names. Since A is C5H12O, it is linear also. Then draw 5 carbon atoms, put OH on carbon number 1, you obtain 1 pentanol. Then move OH to carbon number 2, you obtain 2 pentanol. Then move this OH to carbon number 3, it is what? 3 pentanol. You can't move it more. Part 3. Catalytic dehydrogenation of A leads to the formation of compound B. List the possible chemical families of B. So, if A, which is one of these isomers, if it undergoes dehydrogenation reactions, it will give us B. What will this be with this compound B? It will be either an aldehyde or a ketone, isn't it? Dehydrogenation of primary alcohol will give aldehyde, and dehydrogenation of secondary alcohol will give us ketone. So this is B. It will be aldehyde or ketone. Finally, specify the class of A. Knowing that B cannot reduce potassium dichromate solution in acidic medium. This B, which is either aldehyde or ketone, cannot undergo oxidation reaction with potassium dichromate. So B, aldehyde or ketone? Of course ketone, because only ketones cannot undergo oxidation reactions. We have seen that aldehydes can undergo oxidation reactions. So B is a ketone. Okay, if B is a ketone, will A be a primary alcohol? By oxidation of A gave us ketone. So, will A be a primary alcohol? No, it will not. Of course, A is a secondary alcohol because only secondary alcohols give us ketone by oxidation reactions. So this is the end of mild oxidation. Okay, secondary alcohols can make a mild oxidation to give us ketones, and tertiary alcohols cannot make reactions at all with oxidizing agents. Information are taken from the Liluna National Tech, and thanks for your attention.